Thank you so much, Prashant. You can get started. Give him a big round of applause to start with presentation.
All right, suppose you have a simple hot dog versus not hot dog classifier. You give an image of hot dog to your machine learning model, and hopefully it classifies it as, yep, this is a hot dog. And you give it an image of something else, say pizza, and it gives you an answer that, OK, this is not hot dog, right? So when you deploy this kind of a machine learning model in production, how do you ensure it achieves or it has 90% precision in production? So whenever you deploy machine learning model in production, generally you will have some constraints on your target metric and then some bounds on those target metrics. For example, our metric of concern here is precision, and we want to achieve at least 90% precision. So depending on your use case, your tasks, and business requirements, generally you will have some bounds. If you're using machine learning for, say, sending automatic replies to customers, you want to be very precise, right? You don't want to provide wrong answers to your customers. So precision in that case becomes very important. So coming back to our simple hot dog versus not hot dog model, how do you ensure 90% precision? So let's look into that. So our machine learning model doesn't actually say something is hot dog or something is not hot dog. What it does for simple binary classification task is just gives a number. So if you give an image of something like hot dog, it will give something like 0.8128 number as an output, right? And if you give something else, some image of something else, it will give some other number. So how do we get a final result that something is a hot dog or not? So what we do is we use something called a sigmoid function. The feature of sigmoid function is its output is always between 0 and 1, no matter what the input is. And we use 0.5 by default as a threshold. So if our model produces a number which is higher than 0.5, then we say the prediction is 1, which in our case means it's a hot dog. And if the prediction is less than 0.5, then we say that its prediction is 0, and in our case, that means it's not a hot dog. So coming back to our previous example, the prediction for hot dog image was 0.8128. That means we'll say, OK, model predicted that this image is a hot dog, and similarly for the other image. So suppose now you have a test set of lots of images. So for each of those images, you can pass them to your machine learning model, and you get a prediction score for all of them. And now for Now for all of the prediction scores, you can compare them with a threshold of 0.5, and you can get what the model predicted, whether it's a hot dog or not hot dog. Now since this is a test set, you also have ground truth, which means you actually know whether each of the images are hot dog or not. So you have ground truth here. And as you can see, sometimes the model does make mistakes, right? So you can summarize these classification as a confusion matrix, and you can summarize it in a 2D matrix, and you can say, like, out of, say, how many times model predicted something was hot dog, and it was actually hot dog, and how many times something model predicted as hot dog, but it was not actually hot dog, right? So similarly, you can calculate other metrics as well. So we are concerned about precision. Precision means out of total times model says something is positive, in our case hot dog, how many times it actually is hot dog or positive. So that means the total time model predicted something was hot dog is like 540 plus 312. And actually, it was only 540 times correct. So precision is 540 divided by sum of 540 and 312 in this case, which is like 63% precision, right? So now we are at 63% precision, but we want our production model to have 90% precision. What do we do about this? So we come back to our sigmoid function, and initially we use the default threshold of 0.5. But there's no rule that we have to use the threshold of 0.5, so you can use 0.6, 0.7, 0.4, whatever you want. So what you do is you try lots of different thresholds and calculate precision and recall of your model or some other metrics of your interest at each of those threshold values, right? And as you see, like, when you increase the threshold, model only predicts something as positive when it is more confident. So that means if you increase the threshold, the precision of the model is going to increase. However, since the model only predicts something as positive when it's very, very sure, that means the overall number of times that it's going to produce positive result is going to decrease. So that means recall of the model is going to decrease as you increase the threshold. So this is the typical relation you will see between precision versus threshold and recall versus threshold and different kinds of tasks. So how you go about doing this is you pick your different threshold values that you want to try. So here we are trying from 0.01 to 1 at increments of 0.01. You can choose the granularity based on your tasks, so 0.02 or 0.005, whatever you want. And then for each of those thresholds, you calculate true positives, false positive, and false negatives, and then you calculate the precision and recall at each of those thresholds. And then you can plot your precision and recall at each of those different thresholds. And finally, when you have calculated precision and recall at all the thresholds, you pick the lowest threshold at which the model achieves the 90% precision. So in this case, model achieves 90% precision at 0.91 threshold. So when we deploy our model to production, we are going to use 0.91 as the threshold instead of the default 0.5. Similarly, if you have any other metric of your concern or any other bounds for your metric, similarly, you will try plotting those metrics across different thresholds, and then you will use the lowest threshold at which you are able to achieve those values. All right, so this talk is about sending automatic replies in customer support, and the focus is on developing a highly precise system. So the threshold tuning that you saw, like calculating thresholds at different, calculating precision and recall at different thresholds and finding a suitable threshold for your model, this is one of the main techniques that we use to ensure that the model that we deploy in production has enough precision. All right, so I'm Prashant, and the contents of this talk and the slides you can find in our GitHub repository, and the QR code for the repository is present there in the bottom right corner of the screen. So I'm a machine learning engineer at Mercari, and I've been working there for the last 5 years. If you don't know Mercari, Mercari is like a C2C marketplace. That means any user can list items that they want to sell, and any other user can buy those items. As of now, I think we have around 23 million monthly active users. And that means sooner or later, some users are going to face problems. And if they are going to face problems, they have to contact the customer support operations team. So our team developed features using machine learning that ensures we can provide quicker resolution to the customers when they face problems. In addition to that, we also develop features for our customer support associates. Last year, I also gave a talk here about one of the other projects of my team that we worked on, which was about how do you route different kinds of customer inquiries to a suitable customer support associate. You can find me on like most of social sites under my handle, which is present on the screen. All right. So AI and customer support. So generally, if you have like contacted any customer support and there was like chatbot kind of thing, chances are you did not have a good experience. Even in the state-of-the-art models that we have now, there are like the chatbot models make so many mistakes, like they will often fail to understand the nuances in your problem, and they might keep repeating same answers again and again. One of the biggest problems you will see in customer support wherever they use AI in chat, AI is, it is very, very hard to escalate to actual human agent, right? You cannot get in touch with human agent at all. That's becomes very hard. So if AI has all these kinds of problems, why do we actually want to use AI in our customer support? Now, if you are a business, then obviously it does make sense, right? If AI is replying on your behalf, then you need smaller amount of resources to handle all your customer support operations. So there will be lower operational cost, and then you can divert that cost to some other initiatives, maybe towards growing the company or some other initiatives. Also, generally, the demands of customer support can vary due to seasonality or due to some unintended consequences. So suppose if you slip a bug or something, suddenly the amount of customer inquiries can increase. And in that case, it's very hard to immediately increase the number of customer support associates that you have. So AI can also work well in those cases because you can scale it almost instantaneously. So there are all these kinds of benefits to businesses, but what about users? All right, so I want you to take a look at some sample inquiries. What do you see? All of them are about returning or refunding certain products that the users bought. Return and refund policies of companies are generally quite well documented. Take a look at another set of inquiries. This is mostly about tracking the status of the product that the user has bought. Again, given the shipping method, how you find the status of your product is actually quite trivial as well. So what I want to convey is that even though there are lots of inquiries where you need nuances, where you need to handle with care, there are also tons of inquiries where you just need to convey some information, and the problem would be resolved in that case. Also, no matter how good your FAQs and guides are, there is going to be certain fraction of users who ignore those and just directly ask questions to customer support team. Now at Mercari, we do not have a live chat support. So we have like Monday to Saturday business hours for customer support associates. So suppose you have a trivial problem and you ask a question during non-business hours or on like say Sunday or something. So you might have to wait a few hours to a few days to get back a reply for trivial questions. And that is not good for a good customer experience, right? So if we use automated answers for some trivial questions, we can provide almost instantaneous reply. That can mean quicker resolution to customer's problem if it is trivial. And of course, it's available all the time. So now that we see that it's beneficial to our users and it's beneficial to us as a business, then we decided to start using AI in our customer support operations. So we had two main considerations that we wanted for our AI system to have. The first one is we don't want to send automatic reply to all inquiries. That's not the goal. We only want to send an automatic reply if we are really, really damn sure that it's going to solve the customer's problem. For the rest of the talk, we'll see how we develop such a precise system. And another main consideration is it should be very, very easy to escalate to any human agents. For that, what we do is there is one-click escalation to customer support agents, and also we send automatic reply only as the first reply, and if there are any further messages, then that's handled by human agent so that users do not get stuck in a loop or something. All right, so now if you want to develop your automatic reply system, so first you have to look into the data of your customer inquiries. There's going to be very, very different categories of inquiries like shipping, payment, login-related issues, and not all of them can be automated. Some of them actually do need to be handled by human agents. And even if you can automate some of them, you cannot automate them with high precision, right? So at least when you are starting, the most important point is you should be able to identify categories of inquiries where you can automate them with high precision. So how you go about doing that is obviously take a look at lots of different kinds of inquiries and what kind of responses were provided by CS agents. And then you also look at different segments of your data, like different categories of inquiries, grouped by different shipping methods. And you also take a look at what response templates were used by CS agents and which one of them were the most frequently used ones. And then you look inside those data to figure out, does it require any additional action, or can this potentially be automated? And the most important one is talking with domain experts. So in our case, that means talking with customer support operation team. They have knowledge about how you handle different kinds of inquiries, what's the procedure of handling different categories of inquiries. So definitely talk a lot with domain experts, whatever problem you are trying to solve. Once you have identified a group of inquiries that would be suitable for automatic reply, you need to do a few more things so that your system has high precision. Take a look at this inquiry. So here the user is saying that they bought something a few days ago, but the item has not shipped yet. What should they do? Now, if you only take a look at the text of the inquiry, it's quite hard to answer because whenever a purchase is made, the seller receives few days, like a deadline until which they can ship the item, right? If the deadline has not exceeded, then your reply would be, okay, please wait until the deadline for the seller to ship the item. However, if the deadline has passed, then your response would be something like, okay, let me contact the seller, and if they do not respond, say, within 24 hours, you can cancel the transaction and get a full refund. So here, what's the shipping deadline is and has it exceeded or not, this is a critical information to correctly answer the question of your user. So utilizing metadata becomes very, very, very important if you want to develop a highly precise system. In our machine learning model, along with the text of the inquiry, we use lots of different metadata. So some of the important ones are whether the inquiry is from buyer or seller of an item, what's the transaction status, like is it waiting for shipping, is it already shipped, is it already delivered or not, what's the category of item, what's the shipping method, like is it shipped using Yamato or some other different shipping methods, what's the price, are there some restrictions on seller or not. So we use all different kinds of metadata. All right, so now for each inquiry, we have the text of the inquiry along with all the metadata that we have collected for that inquiry, right? And we collect these for, like past 12 months or whatever, so that we can have a data set that we can use to train our machine learning models. Now for each of all of these inquiries, the actual responses were sent by the human customer support associates, right? So we also have the data about which reply template they use to send the response. So basically, for each of these data points, we also have the labels. So we can go about building and training our machine learning models for this task. Since both our inquiry text and metadata are like text, so transformers are very suitable for this kind of task because we want to do classification and the inputs are text. So transformers were introduced back in 2017, and they are like the state-of-the-art architecture for all kinds of NLP tasks. All the best models, even the generative ones, like GPT models, use transformers architecture, and you can find many, many different kinds of pre-trained transformers on massive amount of data that you can fine-tune on your downstream task. The good thing about transformers is like they provide contextual understanding of your text. That means they don't just look at each word in your sentence individually. They take into account how each word is used in the context of that sentence. Now, transformers generally have two different parts, like encoder and decoder. So if you want to generate, transformers, they are used for like text-to-text tasks, like you provide a text in English and it can translate it to Japanese. But if you only want to do, say, like represent your sentence as a vector, then you only need the encoder part, and the generative models now, like GPT models, are only actually decoder models. So how it works is like, say, you have a input text. You first do the tokenization, so pass it through a tokenizer. It separates text into chunks, and then it's encoded into numerals. And finally, you pass it to your transformer encoder, and basically, at the end, you get a vector of numbers. Once you have a numerical representation of your numbers, what you can do is like add a softmax layer on top, and you can train a machine learning models for text classification. So if you want to do like text classification like things on Japanese text, there's a really, really nice repository on GitHub, awesome Japanese LLM. So they have a list of all the different kinds of not only generative models, but also encoder models, the screenshot that I've added here. And you can see what are the architectures for them, and most importantly, what's the license for them, like can you use them commercially or not. So as for my recommendations, so suppose you want to do some text classification tasks in Japanese, so good starting point would be using the Distilbert model by line. And Distilbert model is quite small, so it's very fast to train and very fast for inference as well. So it's a good baseline model for your text classification task. And if you want to improve your performance, you can move on to bigger models like BERT or Roberta. If you have multilingual data set, good starting point would be XLM Roberta model by Facebook. So you can try that as a starting point, and then further try different bigger models like Roberta Large or something. All right, so far we have our inquiry text and our metadata text. So we don't just concatenate them, we add them together using a special token called separate token. This is used in language models like transformers to signify like two chunks of text are like semantically different. So we concatenate them together using separate token and then pass them to our transformers like Distilbert model, which we use, and which gives us a vector or embeddings for the text and the metadata. And then we have a few more fully connected layers on top. And finally, we have softmax layer, and we train this end-to-end to get our machine learning model. All right, so after you have your machine learning model ready, what you need to do is the threshold tuning thing that we saw in the beginning of the talk. So basically, in our case, we want to achieve 90% precision. So we calculate threshold at all, calculate precision at all different thresholds, and pick out the thresholds that are suitable for us. One thing you have to note here is that in the example in the beginning, we saw threshold tuning for a binary classification task. In our case, there are multiple different classes. So generally, you have to find thresholds for each of those different classes because we are doing multi-class classification task. All right, so now that you have your model and you have figured out what threshold you should use, let's take a look at one of the actual template responses that we use at Mercari. So I have like translated it and made some modifications, but the gist of it is like, it says, we have notified the seller to ship the item within 24 hours, and if the seller does not ship or does not respond, then you can proceed to cancellation, right? So think about this template. It does not make sense to send this template if someone is actually a seller, or if the shipping deadline has not passed. So the thing is, your machine learning models, even after providing all the metadata, can still make mistakes. So you have to use your domain knowledge to create certain kind of rules. So for example, for this reply template, we create rules like only send this template if the inquiry is from buyer of an item and the shipping deadline has passed. So similarly, for all different reply templates that we send automatically, we have different criteria. So for example, some template could only be sent if the shipping method is something particular. So this acts like a final line of defense in where you try to do sanity check that you are not sending a wrong response. All right, so at inference time, the flow goes like this. You receive a new inquiry. First, you gather all the relevant metadata. So since we are using many different kinds of metadata, we have to make calls to many different microservices and gather like price, what's the restriction on seller, what's the shipping deadline. You get all these metadata by making calls to different microservices. After that, you anonymize your inquiry text to remove all the personally identifiable information, and then you do pre-processing on the text. After that, you send the metadata as well as inquiry to your machine learning model. Then machine learning model makes some predictions, and it compares against the threshold that you have already calculated. If the prediction is more than the threshold, then your ML model will suggest, OK, you should send this template as an automatic response. Then for that particular template, we again check all the domain rules that we have created. And if all the domain rules are satisfied, then we finally send that response as back to the customer. All right, so now that we have developed our machine learning model, we have the inference flow. Before we fully deploy it in production, we do need to test if it actually makes an improvement or not. So in our A/B test, the goal of improvement is like reducing average number of manual reply that we send per case. However, we do want to make sure that there are no negative effects because of that. So as a guardrail, we use what's the resolution time per user. And this helps us ensure that overall operation time is not increasing because of sending auto reply. This is from the business perspective. We also want to make sure that the user satisfaction is not degrading because of automatic replies. So we also use customer satisfaction score as a guardrail. So far, we have done like 2 major releases for this kind of thing. And in the 2 tests, we have reduced like manual replies per case by like 5.5% in the first one, and another 1.3% on top of that in the second one. And so far in both tests, we did not have any negative impact on customer satisfaction, and we actually improved the resolution time per user. In terms of actual operation benefits, through the two tests, we were able to identify like reduction in the total number of hours that you require per month for your customer support operations. We were able to reduce that by like 1,000 hours in the first deployment and another 800 on top of that to the second. And as of now, out of all the replies that are sent by our customer support team to our users, about 5% of them are automatic replies. So as I said earlier, our goal is not to send automatic reply to all the inquiries, only when we are very, very sure that it's going to help our users. All right. So in our talk, we learned how to develop a high precision system for text classification. And we saw like it's very crucial to utilize metadata in your classification, because without metadata, it's quite ambiguous to determine which template you should use. We also saw threshold tuning for machine learning models, and this is something you can use for all kinds of different tasks involving machine learning to find suitable thresholds for your tasks. And finally, we saw like just using machine learning is not enough. You should combine it with rules based on your domain knowledge so that you can ensure good precision or good performance from your machine learning model. That's all. Thank you.
Thank you so much, Prashant. We still have more time, so if there are any questions, we can give a bit.
Thanks for the talk, but
Yep.
do you have any example code of how do you have any like samples of like some open data sets that you could share or anything like that to actually do some of the training, like any sort of notebooks that could be followed just to sort of get an idea of how to build something like this out ourselves?
Right. So generally, the main repository for all these kind of models, you can find them on Hugging Face quite easily, and there are like lots of tutorials about how to do fine tuning like this. And we have like so much, like last 3-4 years, we have so much progress in machine learning field that actually to build a model like this, you only need like 10 to 15 lines of code. So it's actually very, very easy. And in terms of data set, so there are already lots of fine-tuned models on large data sets available. And like something like Japanese Wikipedia corpus, so there are already models that are fine-tuned on that. Common Cold data set, that you can find models that are already fine-tuned on that. What you need to do is like figure out what your downstream task is. So in our case, we wanted to predict which reply template would be suitable for a given inquiry. So this kind of data set you have to curate yourself based on your task, and then you can fine-tune your model on that task.
Just wondering, what size are your data sets that you're working with then? If you can share it.
Yeah. So right now for these kind of Distilbert models, we did some experiment and figured out like using last 12 months of data, like training and tests works best. So last 12 months comprises about like, I don't know, 5 to 6 million rows of inquiries.
Oh.
Yeah.
Cool. Thank you.
Hello. I noticed that you mentioned some BERT-related models. So I wonder, did you use some recent LLM for your models?
Yeah, LLMs are suitable for like generation tasks. If you want to do say text classification, and you have good enough amount of data. So as I said, like we use 5-6 million inquiry and label pairs. So in that case, smaller models like BERT fine-tuned on your own domain data is going to outperform general LLMs all the time. So if you have enough data, always use these smaller models. And another benefit is like they're faster, easier to deploy, and less costly.
Hello, thank you very much for the great talk. I was kind of curious about the productionization of these models, etc., because I guess the customers expect like a fast response time. I don't know what kind of load you're dealing with in production. Can you talk a little bit about the challenges you've had
deploying such models and architecture and orchestrating
Right. So once you have created your model, what you do need to figure out is like what's the amount of traffic that you're going to be serving in production. So once you have like say some 10 RPS, 50 RPS, whatever you have. So what we do is we use TorchServe, if you are familiar with TorchServe. So PyTorch is something we use for training the models, and then we use TorchServe for serving the models. So basically you containerize your model and we deploy it on Kubernetes. And once you have created your deployment and you are ready to serve, basically what you need to do is do a load test through mock data. And in our dev environment, we basically calculate what's the peak RPS that we expect based on the past production data, and then we do load testing and make sure that latency is within whatever we set our SLO. Yeah. Yes, we are using that. We are using the metadata, all the metadata that I showed earlier in both training and at inference time. Yeah.
Any more questions?
Yeah, you can. Go ahead.
You can talk. There is a mic issue. You can ask.
Right. So as of now, so our interface looks like kind of like a typical chat UI. So users can send a message, agents can send a message, back and forth, right? So our automatic response only is sent as the first response, and if there are any follow-up message from the users, the subsequent messages are automatically they are automatically sent to the human agents, and then they reply. Not always. So if our models finally feels like, okay, in this case, our model is very sure that we should send automatic reply, then automatic reply is sent. And if automatic reply is sent, if there are any follow-up messages, then human agents handle that.
Yeah. Any more questions? So Prashant will be here around in the hallway or something. So if you have any more questions, you can catch up with him and ask your questions. Once again, thank you so much, Prashant, for your wonderful presentation. Please give him a big round of applause.
Thank you.